Confused about wave-particle duality? Let me tell you a story, it might just help. So, it all started by a time when light's curiosity made him wonder about the true nature of his existence. So he went on a journey to ask a couple of physicists. First, he met Isaac Newton. Newton believed that light was a particle, and since it travels in a straight line, he suggested that it's a line full of little particles which are produced by a source and reflected by objects. But then he came across Huygens, who believed that light was a wave, and he used his wave theory to explain diffraction. He also said that light needs an environment to move in and called it ether, which actually does not exist. Well, Light wasn't convinced and had to wait for nearly a century till Thomas Young performed a double-slit experiment, which supported the wave theory. He believed that when two waves meet, they interact with each other. In order to prove that, he shone a beam of light on a screen with two narrow slits. When passing through every slit, light bends. Then we have two waves that interact with each other. Well, if you look at this from the side, we have a view like this. Where two mountains meet, they combine to make a larger wave. But when a valley and a mountain meet, they destroy each other. That's why we have the interference pattern at the end of the wall. And this shows that light is a wave, because if it was a particle, we would have only two narrow lines at the end of the wall. Well, then light is definitely a wave. But this is not where the story ends, because in 1905, Einstein came up with the explanation of the photoelectric effect. It simply says that when light is shone on a metallic surface, if it's strong enough, it can make the electrons to pop out of the nucleus. Great question. Well, based on the wave theory, the energy of a wave depends upon its amplitude, or basically the brightness. But in experiments on the photoelectric effect, it turned out that it actually depends on the frequency. So, since wave theory failed to explain this, then light is not a wave. But we know it's not a particle either. Well, then what else could it be? To the answer of this question, Einstein said, you know what, let's mix these two up and the result would be light is a wave and a particle at the same time. It's made of these little packages of energy which we call photons, and a stream of these photons is a wave. Well, it's kind of like a cylinder. It can't be just a circle or only a rectangle, it's both at the same time, right? After a while, Luigi Boy proved that this concept applies for all matter, even us humans. But we're just a tiny bit massive to be able to act like a wave.
So you see, just by being curious, you can learn a lot. All you have to do is not to settle for short answers and always ask why. Because curiosity always leads to a better understanding.